Hey, wait the minutes. Ever sit in math class like, bro, why are we learning this Pythagorean triangles? It's literally just a square plus b square equals c square. You probably thought, this tiny formula? Never gonna use it, ever. But guess what? Pythagoras is actually kinda cracked. OP bro.
Isn't that amazing?
It's maybe ancient, but this dude's formula be solving problems like real-world puzzles, architecture stuff, survival mode navigation, and yeah, even flexing your brain to be Sigma boy.
My Sigma boy, Sigma boy, Sigma boy.
Sup, I'm Fidia. Today, I'm taking you on a wild ride through the world of Pythagoras. Don't scroll, don't blink, and definitely don't skip. I promise it's gonna be cool. Hey guys, imagine if the world didn't have the Pythagorean Theorem. It looks like it's going to be really messy. This time we will get to know the material of Pythagoras, the savior of the world of calculation. First, let's discuss a world without Pythagoras. Imagine, you are crossing a bridge. Suddenly, GeoGebra. Look at videos. Why? Because engineers forgot to use the Pythagorean theorem. Ha ha ha. Next, imagine you live in an apartment on the 30th floor. And the building is tilted like the Tower of Pisa. And imagine you are in a hurry, open the GPS. And instead you are told to go around the complex, instead of getting closest road. All that could be messed up without Pythagoras. Hello everyone, we will discuss a figure whose name we often hear when studying math. Yup, who else if not Pythagoras? But, did you know that Pythagoras was not the first discoverer of the Pythagorean theorem? Let's go deeper.
Who doesn't know the Pythagorean theorem? This right triangle formula, which reads a squared plus b squared equals c squared, must have appeared very often in math lessons. But did you know, Pythagoras wasn't actually the first inventor of this formula? Let's take a trip back in time to get to know the people who helped shape this legendary theorem.
The Pythagorean theorem is not just the work of one man. The concept was already known by the Babylonians, Egyptians, and Chinese thousands of years before Pythagoras formally proved it. In fact, in the 19th century, US President James A. Garfield also contributed to its proof. So, this theorem is the result of contributions across time and cultures. This journey started long before Pythagoras was born. Around 1900 BC, the Babylonians already understood the relationship between side lengths in right triangles. They didn't write in Latin of course, but their clay tablets recorded calculations that indirectly reflected this theorem. Even the ancient Egyptians used this concept to build the pyramids. How can you fit triangular stones together if you don't know the side lengths? Jumping to ancient China, around the 1st century BC, there was a classic math text called Zhoubi Suanjing. In it, there is an explanation of a right triangle showing the relationship between its sides, which is very similar to the Pythagorean theorem. In fact, they used the visual aid of a Gogu diagram, a kind of right triangle, to explain this principle. Although it was not yet written down in the form of the formula a superscript 2 plus b superscript 2 equals c superscript 2 as it is today, the basic concept was already understood and applied, for example, to measure shadows or the height of buildings. So while it hasn't been proven in a formal mathematical way like Pythagoras did, the principle has been around for a long time in China. Well, it wasn't until around 500 BC that Pythagoras emerged in Greece, precisely from the island of Samos. He was not only a mathematician, but also a philosopher and leader of a spiritual sect known as Pythagoreanism. Although he was not the first to discover the relationship between the sides of a right triangle, it was Pythagoras who is credited with providing a logical and systematic proof of the theorem. He formulated clearly that the square of the length of the hypotenuse is equal to the sum of the squares of the other two sides. A superscript 2 plus b superscript 2 equals c superscript 2. Pythagoras' specialty was how he brought this concept into the framework of formal science in the Western world. His proofs were not just based on experience or tradition, but used the deductive method that is the basis of modern mathematics. In addition, Pythagoras and his students viewed numbers and geometry as fundamental to understanding the universe, so the theorem also had philosophical and spiritual value. But apparently, the history doesn't stop there. In the 19th century, the 20th President of the United States, James A. Garfield, yes, the President, also contributed a version of the proof of the Pythagorean theorem. Even before he became president, he showed a simple and elegant geometric proof using a trapezium. Pretty cool that a president contributed to the world of math. So, although Pythagoras is the iconic name of this theorem, contributions to its concept and proof came from various times and places from Babylon, Egypt, China, Greece, and even the United States. This theorem is truly the result of collaboration across civilizations and generations. It's not just about math, but also about how knowledge develops from hand to hand, from one idea to another. Hey guys! Let's talk about the OG triangle wizard, Pythagoras. It's just a square plus b square equals c square. Sounds simple, right? But yo, this formula's got some serious superpowers. Even though it looks the theorem is so simple, this thing can solve crazy real-life problems, like distance, height, object position, and so on. This theorem is like the foundation of a ton of stuff. Trigonometry, yup. Analytic geometry, check. Physics and technology innovations, double check. Do you know how many ways the Pythagoras theorem has been proven so far? 1, 2, 100? No, there are over 300 different ways to prove the theorem. Can you believe it? It's just one formula, but people have come up with hundreds of proofs. From ancient Greek geometry to algebra, even folding paper origami style. Guess what? Some of those proofs were discovered by students, teachers, even a US president. Yeah, James Garfield had one. So who knows? Maybe you could be the next person to create the next proof. Guys, did you know this formula has its own squad of special number combos? Say hello to the Pythagorean triples. So, what are these triples anyway? They're like 3 whole numbers that perfectly fit the rule. Let's say 3, 4, 5, or 5, 12, 13, or 7, 24, 25, or 8, 15, 17, and there are infinite Pythagorean triples. It's like Pythagoras left behind a secret club of triangle numbers. And guess what? You can make your own triples too. Wanna try? Yo guys, these Pythagorean triples existed even before Pythagoras was born. Way back in 1800 BCE, the Babylonians were already doing triangle math. Check out this clay tablet called Plimpton 322. Some experts say it's basically a chart of numbers that line up perfectly with what we now call the Pythagorean theorem. Boom! No calculators, just vibes and genius. Whoa, what's this? A magic door? Let's find out. Yay, welcome to Egypt. Look at the pyramid. Did you know that Pythagorean theorem can help you build things super straight? Yup. If you have a triangle with one corner that's a perfect 90 degrees, this theorem tells us how the sides need to line up. Engineers use it all the time, even way back when building the pyramids. They used the Pythagorean theorem to make sure everything stood tall and straight. No leaning towers here. In ancient Egypt, they had these squad of land measuring legends called the Harpagonapti, also known as the rope stretchers. They used a 12-knot rope to make perfect right angles. Like, literally a triangle with sides 3, 4, and 5 knots, the OG Pythagorean triple guys. They weren't just doing this for fun, they used it to divide farmland, measure plots, and make sure buildings were built straight and solid, like ancient architects with triangle superpowers. When you learn about the Pythagorean theorem and feel like, oh, when am I ever gonna use this? Well, surprise! This triangle trick is actually everywhere, guys. Let's go! Okay, picture this. You gotta move a big box up into a truck. You got a ramp, and you know the height and the base. But how long should the ramp be? Boom! Just use the Pythagorean theorem. Height square plus base square equals ramp square. Problem solved. Next, have you ever seen those ads that scream get your big 55-inch smart TV now? But like, 55 inches what? Width? Height? Diagonal? Here's the plot twist. That number is the diagonal of the screen. Yup, the line from the bottom corner to the opposite top corner. And guess what math lives there? Our king Pythagoras. So yeah, in other words, the Pythagorean theorem also helps measure the size of your TV screen, your computer monitor, or even your phone. Pretty cool, right? Math is literally all around you. Guys, you are probably thinking that the Pythagorean theorem is just boring school math, right? You're out here saying, I'm chill, I just play games, not trying to do math. But bro, that boring triangle math, it's in your game, every single time you move. Yeah, that's right. In video games, devs use the Pythagorean theorem to make characters walk diagonally from one point to another. Your game is using Pythagoras behind the scenes to keep it smooth. You're literally gaming with math and don't even know it. Ever used Google Maps? Yeah, that thing finds the shortest distance between two spots and guess what's behind it? Yup, Pythagoras. When you're trying to figure out where you are on Earth and satellites in space are helping you out, that's what GPS does. It talks to a bunch of satellites to find your exact location. But here's the cool part. To figure out how far you are from each satellite, GPS uses the Pythagorean theorem. The satellites know where they are. GPS measures the distance to them using Pythagorean theorem but in 3D. So yeah, the Pythagorean theorem, just like the ninja math skill hiding behind stuff we do and use every day. Hey, today we're gonna check out how to teach the Pythagorean theorem to students. And nope, it's not me who's gonna explain it. Let's go meet Miss Cindy. Hi Miss Cindy. Everyone's wondering how you'd break down the Pythagorean theorem for students. Would you mind teaching us as well?
Sure dear. Let's go to classroom. There are many ways to teach the Pythagorean theorem to students. For example, we can use visual learning media like interactive diagrams, educational videos, or even apps like GeoGebra to help them understand how the formula works in right-angled triangles. Another effective approach is through innovative teaching models, such as problem-based learning, PBL, project-based learning, PJBL, discovery learning, or even ethno-mathematics-based approaches that connect mathematical concepts with students' cultural backgrounds. These strategies help make the learning process more structured, meaningful, and interactive for students. And here, I'd like to show you one method that's especially effective for explaining the proof of the Pythagorean theorem to students, using GeoGebra. With GeoGebra, students don't just memorize the formula, they can actually see the proof unfold visually, which helps them understand the concept more deeply.
As we all know, the Pythagorean theorem says that if we have a right-angled triangle with sides A, B, and C, where C is the hypotenuse, then A squared plus B squared equals C squared. Now, let's try to prove it in a visual way using GeoGebra. First, I'm going to create a right-angled triangle ABC, where point C is the right angle. Side AC is the hypotenuse, which we'll label as side C. The other two sides are A and B. Now, let's move on to the geometric proof of the Pythagorean theorem, which says C squared equals A squared plus B squared. We begin by drawing a square on each side of the triangle. One on side A, one on side B, and one on the hypotenuse C. Since the area of a square is the square of its side length, we have area A squared for the square on side A, area B squared for the square on side B, area C squared for the square on side C. Next, we cut the squares on A and B into specific parts. Then we slide and rearrange those parts carefully. Now look, all the pieces from the A squared and B squared squares perfectly fill the square on side C. There are no gaps, no overlaps. Every part fits exactly. This visual arrangement shows clearly that the area of the square on side C is exactly equal to the combined areas of the squares on sides A and B. So, using this geometric approach with GeoGebra, we've proven that C squared equals A squared plus B squared. Using GeoGebra makes it easier for students to understand the Pythagorean theorem. Instead of just memorizing the formula A squared plus B squared equals C squared, students can see the proof visually. How the areas of squares on sides A and B perfectly fill the square on side C. This helps make abstract math concepts clearer, concrete, and engaging. GeoGebra also supports critical thinking and exploration, making learning more interactive and meaningful.
Thanks a lot, Miss Cindy. That was such an interesting explanation.
You're welcome. And for all teacher friends out there, if you'd like a tutorial on how to make this Pythagorean theorem proof using GeoGebra, just check the link in this video's caption. And see you guys.
And yep, we've made it to the end of the video. We've talked about the Pythagorean theorem, who came up with it, how it's used, and how to explain it to students. Alright, that's it from me. Thanks a lot for watching, and see you in the next video.